Welcome all. This is Padma Priya, Assistant Professor in the Department of Computer Science and Engineering, SSM Institute of Engineering and Technology, Dindigul. In this video, we are going to discuss a topic on computer architecture and organization. In this video, we are going to discuss topics on basic operations of a computer and 8 great ideas which are all used to develop computer. So what are the basic operations of a computer? Fetch, decode, execute, and store. What is fetch? Fetching means fetch the instruction from memory, taking the instruction from memory. And understanding the instruction, that is decode. Understanding the instruction is decode. Performing the required operation is execution. And storing the result back into the memory is storage. So these are all the basics operations of a computer. Fetch, that is getting the instruction from memory, which is differs from read operation, and getting instruction from memory is fetch. Getting data from memory is read. Fetched content can only be executed, but read content can be altered. Decode, that is understanding the fetched instruction. So it will be done by decoding unit. The decoding which sends commands to control unit and ALU to perform the operation. Execution unit which performs required operations like addition, subtraction, multiplication, ALU operations. Okay, so these operations are done by ALU. So operation varies upon the processor type. And store, so which the executor results which will be stored in the memory, and also it is referred as write operation. So there are different methods of storing the result. So this is the state diagram. So here it gets started and the processor will fetch the instruction and it will get decoded. The instruction will get decoded and the instruction will get executed. If you are having more instruction, then the execute cycle will keep on fetch the instruction. If the instruction execution got completed, then the instruction will get halt. So until end of the program, it keep on fetch the instruction. Fetch the instruction, decode it and execute the instruction. So until the end of the program, it keeps on. So after that, it will get halted. So next thing is, we are going to discuss on 8 ideas in computer architecture. So to improve the performance and to build a computer in an effective manner, for the past 60 years, the computer architects or scientists, they invented 8 ideas. First one is design for Moore's law, and second one is use abstraction to simplify design and make the common case fast, and performance via parallelism, performance via pipelining, performance via prediction, hierarchy of memories, and last one is dependability via redundancy. So first one we will go with design for Moore's law. So this law states that integrated circuits, that is number of transistors inside it, integrated circuits resources which doubles every 18 to 24 months. So the computer designers, they need to keep in mind about the Moore's law whenever the invented computer entering into market. Design the computer such that it able to competitive for at least 4 to 5 years. Our design needs to be stable in market. It should maintain competency in market. Okay, so that is the main motive of Moore's law. So resources available per chip can easily double or quadruple between start and finish of the project. So it should be able to stable in market. So our design should based on Moore's law. So this is Amdahl's law, so which stating the performance enhancement possible with a given improvement is limited by the amount that the improved feature is used. It is a quantitative version of the law of diminishing returns. So this Amdahl's law, which is used to make our common case faster. And next idea is use abstraction to simplify design. So it is a major productivity technique for hardware and software. It is to use abstractions to represent the design at different levels. So at different levels, we are going to design our we are going to represent our design at different levels. Lower level details are hidden to offer a simpler model at higher level. For example, OS, kernel, hardware, software. So what is the OS we are using, or what is the hardware we are using, software? So we are not going to depth level. What is the main thing? And that is the abstract level we are giving. And next thing is make the common case fast. So a system can do two kinds of function. So here we are making the common case and rare case. So these are the two functions. Here we are enhancing the performance better than optimizing the rare case. So while we are wasting the time on rare case, here we are motivating the or concentrating on the common case. So instead of wasting time on rare case, we are enhance the performance. To enhance the performance, we are spending more time on common case, so that it makes the design simpler and can be done faster. So for example, if you are designing sports car, then we want to concentrate on the engine. So because sports car concentrate on faster, right? While we are concentrating on a passenger van, so we need more seats. But in sports car, we don't want more number of seats, right? So based on the common case, we are concentrating, okay, so that the performance will get enhanced. And next one is performance via parallelism. By performing operations in parallelism, the performance will get more enhancement. So the speed of the computer system will get improved. For example, jet with multiple engine, it will get more faster. So next one is performance via pipelining. So it is a great example for achieving parallelism. So to improve performance, we are going with parallelism. So a pipeline, it is a set of data processing elements connected in series. So in series format, it will get connected where the output of one element is the input of next one instruction. So the output will be given as input to the second one. As soon as the first activity of an instruction is done, we have to move to the second activity and start the first activity of a new instruction. So here, we don't want to wait for the first instruction to be completed for all activities. So we can suddenly bring the second instruction into the same. So it takes the first instruction and move the first instruction into the next stage and take the second instruction. Parallelly, it will get work. So this is how pipelining concepts get performed. And next one is performance via prediction. Prediction means what? That is future telling. So what it will happen? What are the things going to happen? Like that is the future fortune telling, right? So it predicts the certain conditions executed by the computer in advance so that the decisions will be taken and direct the computer in good manner. So here, branch prediction algorithm, branch predictors, which plays a critical role in achieving high effective performance in many modern pipelined microprocessor architecture. For example, JNC, jump on no carry. So if there is no carry in the result, then the process needs to jump. So it predicts the computer branches in advance and improves the performance in pipelined microprocessor architecture. So next thing is hierarchy of memories. So programmers, they want memory to be fast, large and cheap. So architects, they have found that they can address the conflicting demands with the hierarchies of memories, with the smallest and most expensive memory per bit at the top of the hierarchy and slowest and largest and cheapest per bit at the bottom. While we are going with top level, we will have fastest, smallest and most expensive memory. While we are going with the bottom, it will have slowest, largest and cheapest memory. For example, CPU, cache memory, those are all fastest but smallest and most expensive memory. While we are going with the lower level memory, that is secondary memory, they will be slowest and largest and cheapest memory. And dependability, we are redundancy. So computers, they not only need to be fast, they also need to be dependable. Since any physical device can fail at any time, we make systems dependable by including redundant devices so that we can recover from our failure, and also it helps us to detect failures. So these are all the 8 great ideas we need to keep in mind while we are designing our computer. So while following these 8 great ideas, we shall design a computer in a more enhanced and performance basis. We shall able to get more better performance computer. Thank you all.